Yeah, hello, Ati Kirsten. Okay, so again, I'm so sorry if rusty ang first ako discussion on the factoring of the trinomials. Um, we know that we have our personal way of processing problems, right? So what I did last night, I documented my personal style. Like I organize the process of factoring trinomials. So I hope that this helps. So the agenda of this recording is to give you a walkthrough on that documentation. And I promise you I will still deliver this walkthrough live tonight. Okay, so you know naman you've been very, very supportive of me, and then you really assured that you care for me and that you appreciate what I do, and uh, how you call this one, grateful lang jud ko na maka-answer ko sa inyong mga case, and kanang willing jud ka mo listen sa unsaon pag-answer, and you don't want to just receive answers, but you also want to bring out you want me to help you and help yourself unleash the mathematician in you. Okay, that's what I really like about you. You want to discover the solution yourself. You want to discover your personal way of figuring things out. Okay, that is the mathematician in you. Okay, sige. So here's now my documentation. So pasensya na, this is very raw. Okay, I cannot edit it. So I decided to for you to have something that you can look back after my live discussion tonight. So, pwede ni mo ni balik-balikon. Okay. So, there will be a lot of parts siguro for this walkthrough. There's a limit mo good of 15 minutes for each recording. Okay. Alright, so there are two scenarios, major scenarios. So the first scenario is when the first term of the trinomial does not have a numerical coefficient. So just like this one here, right? So x squared. So the numerical coefficient for this is just 1. Okay, so when I say doesn't have a numerical coefficient, I'm referring to first terms that the numerical coefficient is really 1. Okay, so I have some guide questions here. So what is the numerical coefficient of the first term? And it is 1. Okay, so what is the and then I said here, does that have a numerical coefficient? Okay, let me just make it more specific. Does not have a numerical coefficient aside from 1. Okay. Now, then guide question number 2, what is the number in the last term? So in this example, it is 30. When we have 1 as the numerical factor of the first term, so we just need to find the factor pairs of the number in the last term. So 30. So factor pairs. So we start with the prime numbers 1, 2, 3, 5. So we would identify the prime factors less than the last number. So for example, 30. So we'll try to find the prime factors less than 30. And then pair it with a composite factor. Okay, so for example, if the prime factor is 1, here in 30, the prime factor is 1, for example, then the pair of 1 is 30, something like that. And then if the prime factor is 3, then the pair of it is 10. 3 times 10 is 30. And then if the prime factor is 5, so the partner of 5 is 6 because 5 times 6 is 30. Then if the prime factor is 2, then the composite factor is 15 because 2 times 15 is 30. So this is what we call as the factor pairs. Okay, so again, in making the factor 3, so please start with a prime factor like 3 and pair it with a composite factor. And at the first 10, please do this until we have tried all of the prime factors that is less than the given numerical coefficient, for example, the 30. So, and we now going to have the process step for the trial and error in getting the second term of the binomial factors. So again, because there is no other numerical coefficient aside from 1 for the first term, then automatically for the first term, okay, the numerical coefficient of the first term is 1 and 1. That's why we have x and x. So we don't know the numbers for the second term. So that will be the agenda, the objective of this game. We will be finding the second terms of our binomial factors. So option number 1 will be adding factor pairs. So guide question, is the number in the last term a positive number? So in the example, yes, it is positive 30. So if yes, then we will be adding factor pairs option. So we will just be adding all of the factor pairs for both negatives and positives to see if we can get the numerical coefficient of the middle term. So what do I mean by that? So for example, we have here 3 and 10. So we will add 3 and 10, and then 5 and 6, 2 and 15, and then we have to consider the signs also. So we can have 3, 10, okay, the factor pair 3, 10. So we can add 3, 10, and both of them will be positive. So 3 plus 10 is 13. And then if both of them is negative, so there's also a trial for the factor pair 3, 10, where both 3 and 10 are negative. So negative 3, negative 10, that's negative 13. And then another factor pair, 5 and 6. So both positive, so 5 plus 6, 11. And then both negative, negative 5, negative 6, negative 11. And the last pair, 2 and 15. So both positive, so 2 plus 15 is 17. And both negative, negative 2 and negative 15 is negative 17. Okay. So with this example, x squared minus 11x plus 30. So please observe that we got negative 11 when adding negative 5 and negative 6. Okay? So why is that significant? Because the numerical coefficient of our middle term is negative 11. So the target sum is negative 11. Hence, we just determine the second terms of our binomial factors. Negative 5 and negative 6. So we can then add negative 5 as a second term of the first binomial as shown here, and add negative 6 as a second term for the second binomial as shown here. And option number 2, when are we going to subtract the factor pairs of the last term? So again, we are in a scenario where the first term has a numerical coefficient of 1. Okay. So what is the number in the last term? Is negative 12. So since it's negative, okay, so is the last term a negative number? So if yes, then we'll be performing of factor pairs. okay? Because a negative last term would mean that the second term of the binomial factors do not have the same sign. Okay, so the products of the outer and inner pairs will be subtracted. That's why we have this option, subtraction of factor pairs. So let's consider the factor pairs of 12. What are the factor pairs of 12? So we have 1, 12, 2, 6, and 3, 4. So let's subtract all factor pairs together. Please have two ways of subtracting them by making the signs of the factors to both positive and negative. So for example, we have 1 and 12. So there would be an instance where 12 is positive and there's a trial where 12 is negative. So look at here. So this is the trial where 12 is negative and 1 is positive. And we also have here a trial where 12 is positive and 1 is negative. So this is for the factor pair 12 and 1. And now let's move on to the factor pair 2 and 6. So there is a trial where 2 is negative and 6 is positive. And there's also a trial where it is negative. It is a 6 that has the negative sign. So we have negative 6 and positive 2. And for the last pair, 3 and 4. So we have a trial where 3 is negative, 4 is positive, and another trial where 3 is positive and 4 is the negative number. So we will then add them. Okay, so negative 12 plus 1 is a negative 11. Negative 1 plus 12 is 11, and so on and so forth. Okay, now another question, guide question, what is the numerical coefficient of the middle term? So the middle term is 1. Okay, so the numerical coefficient is 1. So our target answer for the subtraction is 1. So what subtraction sign then produces the difference of 1? Yes, it is negative 3 plus 1 plus 4 is equal to 1. Hence, the second terms of the, okay, so this is the one in yellow, this is the successful trial. Hence, the second terms of the binomial factors are 3 for the first binomial, so we have x minus 3, and positive 4 for the second binomial, x plus 4. Okay, so if we will do FOIL, so we have x times x, x squared, and then for the inner, we have negative 3x, for the outer, positive 4x, so 4x minus 3x is x, okay, and negative 3 plus 4 is 12. So basically, this is, I have to change this to x, okay, right. So I think I'll take a pause. I've reached the 13-minute mark. In the next part, we'll have the scenario where we do have a numerical coefficient. Aside from 1. Okay. And that is not 1. Alright, so please do watch also the second part of the first 10